Let's start with an example, and then we'll generalize it. Let's start with this parabola, y equals x squared. And we know what the graph is going to look like. We'll start here right at the origin. I'm over here on the graph. And then what does this tell us? What does this tell us? Y is the vertical. Right, so the vertical equals is, and then this, the x, that's the horizontal movement that you make. So this is the horizontal squared. So when you make some horizontal movement from the origin, you make some horizontal movement, you square it, and that'll tell you what kind of corresponding vertical movement to make. So let's do that here. We'll start at the origin. I'm going to make a horizontal movement of 1 in both directions. So if I go 1, I square it, I get to 1. Go 1, square it, you get to 1. Right? So this is the basic parabola. Over 1, up 1. Now start at the origin. Make a horizontal movement of 2 to the right or the left. It doesn't matter. You're going 2 units on the horizontal. Right? So the horizontal is 2. You square it, you get 4. So you're going to go to 4 on the y-axis. So 2 to 4. Over here, 2 to 4. Maybe we can do one more. How about if we do 3? Right? So if we do 3, we'll start here at the origin. We'll move over 3. Didn't mean to do that. We'll move over 3, and we'll square it. We'll go up to 9. So let's put a point at 3, 9. And over here at negative 3 squared is also 9. And now as best we can, we'll pass a curve. This curve is called a parabola through these points. I'm kind of missing it, but it's close. All right, so here is the graph, our basic graph, y equals x squared. So what I'm going to do now is I'm going to take that basic function, I'm going to make a negative. Now negative, you could read that sign as negative, or when I see a variable, I like to read it as opposite. If I see a number, I'll write negative, but if I see a variable, I like to write it as, or think of it as opposite. So what I'm seeing here is that the vertical movement that you make is the opposite, right, the opposite of the horizontal squared. And the opposite is coming from that negative sign, right? The vertical is the opposite of the square of the horizontal. So let's plot something here. Let's say if x equals 1, then, all right, what is y? Well, y is what? The opposite of 1 squared. Y is equal to negative 1. So that tells me that if I start at the origin and make a horizontal movement of 1, then the vertical is going to be the opposite of 1, negative 1. So that's going to put us here. So let's start at the origin. Now I'll go over 1. Now I'm making a horizontal of 1. I can go in either direction. But if I go over 1 now, the basic I would have gone up, but now this is the opposite. So I'm going to go down. So we're going to go down here. And then what happens if you go over 2, right? If x equals 2, then you get y equals the opposite of 2 squared. Y is equal to the opposite of 4. So if I move from the origin 2 units in either direction, I will go down 4. Let's do that. So I'll go 2 to the right and then down 4. So that'll put me here, 2 to the right, down 4. And then if I go 2 to the left, I'll also go down 4. Now you can see what's happening here, right? We'll start at 0, 0 again because negative 0 squared is still 0. But what happens now? What happens here? Well, I was at 1, and now I flipped it down here to the opposite of 1. We were out here, what, at 4, and now we're at the opposite of 4. Where do you think the next one's going to be? Well, the next one was up here at 9. Now we're going to get the opposite of 9, so I'll be down at 3, at negative 9, negative 3, negative 9. And let's draw the curve through these points. And maybe you can see why now. This is called a reflection. So this curve here that we just drew is, this is why this is y equals the reflection of x squared. And it's called reflection because we're just taking this curve here, right? We're just taking this curve here and reflecting it about the y-axis. So it's like this is a mirror. This would be the mirror image, right? It's reflection. So we're just kind of rotating it right around here like this. And in part 1 of our discussion on scaling, we talked about number 1 here and number 2. Here's number 3. You get a reflection about the x-axis if that number that you choose as your multiplier, right, here's your multiplier, if it's a negative number. So you start with a basic function, y equals f of x, that's the red, and then what do? You multiply it by something. You have a multiplier, and if your multiplier is negative, it takes the original graph, the original f of x, and just reflects it right around the x-axis. Let's try one here. Let's go with this one here. Say we take y equals the square root of x. Okay, now that one looks like this. When x is 0, y is 0. When x is 1, y is 1. When x is 4, the square root of 4 is 2. When x is 9, the square root of 9 is 3. That's one of those 6 basic graphs that we just need to know, have in our library of functions in our head. All right, so there's the basic graph. And now what do we get if we write it like this? Y equals the opposite of the square root of x. Well, what you're going to do here is just reflect this curve, take that red curve, and reflect it right around the x-axis. So if I do that, maybe you can see that this point here, right, that will stay right where it is. But if I take this point and go around the x-axis, I'm going to end up right here. Let me do that like this so it's not a mess. And then if I take this point here and reflect it around the x-axis, it's going to go like this, right? Just take it here, 2 units, another 2 units, I'll get that point. And then if I take this point, reflect it around the x-axis, I'm down here, right? I got what? 1, 2, 3, so 1, 2, 3 here. And then if I connect those with a curve, well, not a very good curve, but you kind of get the idea that the green curve is the red curve just reflected around the x-axis.